Welcome back, STEM students, to Mampaisan's online classroom. Again, we are still in Module 7, and today we're going to discuss Momentum in Impulse Part 2. Last video, we were able to discuss momentum and as well as the conservation of momentum. This time, we're going to discuss impulse and the impulse momentum theorem. What is impulse? Ayan. Before we define and know things about impulse, let's answer this question. Is it possible to change an object's momentum? Siyempre, yes na yes. Okay? Okay? Okay. So how do we change the momentum of an object? Change in momentum happens when net force is exerted in a given time of impact or collision. Of course, when things collide, most of the time net force is provided. Okay, changing the motion or the state of motion of the object. It could be that the object would stop, or the object would move slower, or it would move faster. Impulse actually is the quantity, the specific quantity that is pertaining to the change in momentum. As you can see here, we have a picture wherein we have the constant velocity and then the one that is not constant velocity. When we say constant velocity, di ba pag sinabing constant, not changing. When velocity of the object is not changing, it is not accelerating, and it is not accelerating because there is no net force acting on it, and therefore, as a result, its momentum will not change. Meaning, its impulse will become zero. Again, magkakakonekta sila ha. When momentum changes, when velocity is constant, we say constant, it means not changing. It is not changing because there is no net force acting on the object. Therefore, the acceleration of that object is zero, as well as the change in momentum. Pag gumagalaw ang isang object, automatically may momentum siya kasi nga momentum is inertia in motion. Pero ano yung wala siya? Although may momentum siya, wala siyang impulse. Bakit? Kasi nga, walang change in momentum. So, magkakaroon lang ng impulse if, number one, there is a change in momentum. And of course, that change in momentum is actually caused by a net force. And as a result, the net force causes an acceleration. So in the second picture, the one that is accelerating, this time there is impulse, there is net force, and there is change in momentum. At syempre may momentum pa rin, okay? So yon, magkakonekta sila, di ba? Next, impulse, again, is the change in momentum characterized by the product of net force and time. Okay? It is mathematically expressed as J, letter J yan, no? Medyo iba lang kapag Cambria kasi yung font, is equal to net force times yung dot dyan, ibig sabihin nun times time. Okay? So, etong si J, ayan, this J represents impulse. This, familiar na kayo dito sa Newton's laws. This one is for the net force. And syempre, lagi na natin ginagamit tong lowercase letter t, malamang that is for time. And impulse is just like momentum, a vector quantity kasi may arrow sa itaas. And then, its SI unit is Newton second. Bakit? Kasi the standard unit for force is Newton, and then the standard unit for time is second. That's why we will use the SI unit Newton second. And then, since as you can see, impulse is the product of a scalar and a vector, it follows the direction of the vector quantity involved in the equation. Therefore, kung si momentum has the same direction as velocity, si impulse naman has the same direction as the net force. From this equation, we could get two more equations. Ayan, to get the net force, you just have to divide um, impulse by time. Hindi yan letter I ha, letter J yan. Bakit letter J? Hindi ko rin alam, no? Letter J yung gusto nila para sa impulse, hindi letter I. So letter J tayo, no? And then if you want to get the time, you just have to divide the impulse by the net force. Siyempre, alam niyo naman ng SI unit ng mga yun, no? So, here are some examples of impulse. If you were in an out-of-control car, would you rather stop by hitting a brick wall or a large haystack? Pag sinabi ng hay, Tagalog yun, dayami. Yung parang pinagtabasan ng, hindi ko alam kasi mga modernong mga bata kayo, no? Hindi kasi ako sure kung nakakita na kayo ng dayami. Ako nakakita lang ako ng dayami, hindi sa totoong buhay. Nakita ko lang yan dun sa ano, Princess Sarah. Kasi si Princess Sarah nagpapakain siya ng dayami. Ano pa nga nagpapakain siya ng dayami sa kabayo. Hindi ko alam kung si Princess Sarah. Basta yung mga unang cartoons, yung di ba mga anime, no? Ayan, nagpapakain sila ng hay or ng dayami. Parang siyang dried grass, dried wheat, or something. Yan. So, basically, malambot siya, no? Or brick wall. Siyempre, kapag tinanong ka niyan, alam mo na agad sasagot mo. Siyempre, masakit kapag sa brick wall ka tumama. Pero kapag sa haystack, ano lang yung parang bulto ng hay or ng dayami, di syempre, mas dito ka na sa haystack. Pero scientifically, we could explain that as the haystack is the smart answer. Not only because it is softer, but both will apply the same change in momentum kasi same naman yung mass ng car na kasama ka, same din yung velocity na nagmo-move yung car mo, assuming na ganon. So, same lang yung magiging change in momentum. Same lang din yung magiging impulse, but the wall will do it over a shorter time. So, will exert more force. Although F times T, pag pinag-multiply mo, would be the same for both. Meron pa ba ako ditong isang Hindi, balikan natin dito. Kung hindi ko pa na So, parehong yung kapag sa haystack ka man or sa wall ka, no? Pareho lang yung magiging change in momentum tsaka yung impulse mo. So, ano yung magbabago? Wait lang. Since conserved ang change in momentum mo, mas malaki yung force na mai-exert mo kapag mas maliit yung time period. Kapag sa brick wall ka, mas maliit yung time kasi mas mabilis kanyang mapapatigil. Diba? So, mas maliit yung time mo. Lower time, which will result to greater force. Ayan. Okay? Tapos kapag sa haystack naman, syempre, mas matagal yung impact time. Kasi usually, magdedire-diretso pa yung kotse mo kasi nga malambot tong haystack. Okay? So dito naman, mas matagal yung time of impact. No? Which will result to lower force. Okay? So, ibig sabihin, kung dito, naka 2 seconds ka, at ang halimbawa, ang change in momentum mo ay 4, syempre hindi ito makatotohanan, no? Let's say na yung change in momentum mo ay 4, para maging 4 ang resulta nung nasa brick wall ka, dapat yung force mo would also be 2 newtons. Ayan. So dito, halimbawa, ikaw naman ay matagal, naging 4 seconds yung time of impact mo, yung force mo, para maging 4 pa rin to, dapat 1 Newton lang siya. Okay? So, mas maliit yung force dito sa haystack compared dito sa brick wall. Okay? Yun lang. Let's proceed with the sample problem for impulse. What will be the impulse of a body moving to the west if it is experiencing a force of 980 newtons for 3 seconds? So we assume that the force is also going towards the west. We have the given net force is 980 and time is 3 seconds. We are looking for the impulse the equation would be net force times time. We just substitute and multiply and we will get 2,940 Newton second west. Ganun na siya kadali, di ba? Doon tayo sa mas mahirap-hirap ng konti, no? Sample problem number 2 for impulse, we have a car moved to the east and experienced a force of 980 newtons. After some time, it turned towards south and experienced a force of 237 newtons. What will be the magnitude of its impulse if its total travel time is 10 seconds? So kung mapapansin mo, dalawa na yung force natin dito. So we have the given force 1 is 980 newtons. Kalimutan ko isulat ang direction. East. Tapos 237 newtons south for 10 seconds. And then we are looking for the impulse again. And to get impulse, that's net force times time. Now, we are going to have two solutions here kasi net force daw. Remember, net force, to solve for it, you must consider the ways of adding vectors. So, kung mapapansin nyo, yung isang vector natin papuntang east, tapos yung isang vector natin papuntang south. So, they will form 90 degrees. So, we will use the Pythagorean theorem to get the magnitude of the force. Since magnitude lang naman yung impulse yung hinahanap, magnitude ng force lang din yung kailangan natin. So that is net force is equal to F sub 1 squared plus F sub 2 squared. Substitute, we would get the net force 1,008.25 newtons. Hindi yan north ha, newtons yan. So again, since the problem is just asking for the magnitude of impulse, we would just need the magnitude of the force. So if ever na hindi lang magnitude ng impulse yung hinahanap, you still have to continue solving this to get the angle as well as the direction. And whatever angle and direction you solve here, that would be the same angle and direction for your impulse. And then for solution 2, since we already have the net force, we just substitute that to net force times t and we get 1 times 10, 10,082.5 Newton second, or in scientific notation, move natin ng ilang place, 1, 2, 3, 4. So that's 1.01 times 10 raised to positive 4 Newton second. Okay? So again, let's have some activity so that we could check if we truly understand the concept of impulse. So ito ulit yung una natin tanong. What is the relationship between impulse and time? Obviously, it's direct. Kasi again, they are in the same position, both numerator. And then between impulse and net force naman, it's also direct because they are both in the numerator. So let's see which one experiences less impulse. Ay, sorry. Yan. Same object tayo, but this time we consider the time. So here the answer would be letter B, less impulse, although they have the same time. Object A will have greater change in momentum since it has greater mass. Nakadepende pa rin siya sa mass kasi yung impulse natin nakadepende pa rin naman siya sa momentum. And then here, ito ulit, same naman yung mass nila. So sino yung mas malaki yung time, siya naman yung magkakaroon ng more impulse. Tapos yung mas maliit yung time, siya yung magkakaroon ng less impulse. So since object A has less time or has less time of impact, it will have less momentum. And then lastly, ito ulit, yung less massive boy natin, and then the more massive boy, magkaiba sila ng time, greater yung time nito, tas greater pa yung mass. So obviously, this one will have greater greater impulse. Pero ang hinahanap natin yung may less impulse, which is object A or the person with less mass. Okay? Yan. So let's proceed with impulse momentum theorem. Okay, according to the impulse momentum theorem, the impulse due to all forces acting on an object, or the net force, is equal to the change in momentum of the object. In symbols, that's J is equal to delta P. Remember, delta is the indication that something is changing. Okay, so coming from that, we would get other expressions which will be very useful in our problem solving about impulse momentum. Remember that impulse is equal to net force times time, and then remember that momentum is equal to mass times velocity. Now, since there is a change in momentum, hindi naman mag-change ang mass niya, so the change is caused by the change in velocity. Kaya yung velocity lang yung may delta natin dito. Okay? Kaya ulitin ko ha, since the momentum changed, it was caused by the change in velocity, not the change in mass. That's why the delta is only together with the velocity and not together with the mass. Coming from that, remember that any variable with delta in it can be expanded as final minus initial. So since we are talking about velocity here, it can be expanded as final velocity minus initial velocity. And then we could get equations for J, or for impulse, for net force, as well as for the time in all of this. So dito si J, pwede mo rin siyang i-equate. So for example, the problem is asking for J, pero ang given ay mass, tsaka initial and final velocity. So pwede mo tong gamitin. So pwede siyang J is equal to M delta V. O kaya, pwede rin yan, expand mo na, pwedeng M times V minus V naught. Okay? Pwede yon, no? Yan. Tapos, para naman kay net force, pwedeng, kung ito ay naka-equate sa delta P, ayan, kung itong gagamitin mo, pwedeng net force, kasi net force times, sulat natin, no? Net force times time, let's say, is equal to delta P. Pwede rin kasi yan. We could get an equation for F if we divide both sides by T. Ayan. So, kailan mo to gagamitin? If you're looking for the force, tapos ang given ay change in momentum at saka time. Remember, ito rin palang change in momentum natin na to can be expanded as final momentum minus initial momentum. Ulitin ko, kapag yung variable natin may kasama siyang delta, lagi siyang expandable into final minus initial of that quantity, no? So, yan. So, pwede natin gamitin to para sa ating force. Pero kapag dito naman siya naka-equate, pwede rin na i-divide natin by T ulit. So, pwede rin si F is equal to M delta V over T. Ayan. Okay? Pwede rin yan. Or, pwede rin natin ngang i-expand na M times V final minus V initial over time. Okay? Pwede rin yan siya. No? So, kapag maghahanap ka rin ng mass, tapos given naman yung impulse, ganun din, you just have to manipulate everything. For time naman, we have, you divide naman by force or net force. Net force. Ayan. O kaya, equals time yan. O kaya, pwedeng time is equal to, ito naman dito manggagaling, M times delta V over net force. So, nakadepende siya sa mga given mo kung alin yung gagamitin mo. Just always remember, J could also be equal to M, delta V could also be equal to M times V final minus V initial. Pwede yon. Pwede ring delta P is equal to M times delta V. Pwede sila, no? Because of the equal sign here. You just have, pwede silang mag-change ng partners. Okay? So that's the impulse momentum theorem in terms of mathematical equations. Okay? Now, actually, the impulse equation can be derived using that, the impulse momentum theorem. That's J is equal to delta P. And remember that delta P is equal to mass times delta V. And remember that acceleration, ayan, acceleration is delta V over T. That is kapag hindi siya nag-start from rest. And we could conclude that delta V is equal to A or acceleration times time. So if we substitute this to the velocity or the delta V here, we could get delta P is equal to mass times acceleration times time. And then continuing that, recall that net force is equal to M times A. Substituting that, we could get delta P is equal to net force over time. Itong part na to, di ba? Yung M times A, equal yan sa net force based from second law of motion. So we could substitute it here. Ayan, magiging net force times time na siya. And then, since J is equal to change in momentum, therefore J or impulse is equal to net force times time. So, dun siya nanggaling, no? So, galing din dyan, no? Kapag halimbawa, given yung acceleration, pero ang hinahanap sa'yo ay impulse, pwede mong gamitin to. O kaya ito, ayan. Okay? Ganon yung purpose nila, no? So that you could solve for a specific unknown na iba-iba yung mga ibibigay sa yung given. Okay? So, here are examples of impulse momentum theorem. Ito, galing to dun sa equation natin kanina. Ayan, this theorem reveals some interesting relationships such as the inverse relationship between force and time. Okay? So for example, ganito, kapag mas mabilis yung inverse yung relationship, 'di ba? So kapag mas mabilis yung pagkakasuntok sa iyo, mas malaki yung mass tuloy yung force na mararamdaman mo. Kapag mas mabagal, 'di ba, obvious naman 'to, halimbawa may susuntok sa iyo. Kapag mabilis mas masakit, tapos kapag mas mabagal, slow motion, no? Mas less yung sakit, no? Killing you softly. Charot. Ayan. So, other examples, ito yung kanina, yung sa hay. Ito yung hay. Ayan pala yung itsura niya, no? Kinakain ng mga kabayo and stuff. So, same yung mass and velocity. Same yung mass and velocity. Pero dito, mas malaki yung time. Kaya, mas maliit yung force experience. Tapos dito naman, mas maliit yung time. Kaya, mas malaki yung force experience. Hindi siya hindi siya interchangeable. Hindi porke maliit yung force, lalaki yung time. Hindi siya ganun, no? Nakadepende siya sa time. Time dependency, force natin, experienced by the object. Let's have the sample problems. Number 1, we have while playing basketball in PE class, Logan lost his balance after making a layup and colliding with the padded wall behind the basket. His 74-kilogram body accelerated from 7.6 meter per second to 0 meter per second in 0.16 seconds. Determine the force acting upon Logan's body. So nakita mo dito, accelerated sinabi niya. Pero ang binigay niya ay velocity. Okay? Because remember, acceleration also means change in velocity. Okay? So our given are the following. The mass is 74 kilograms. The initial velocity is 7.6. And then the final velocity is 0 while the time is 0.16 seconds. We assume that Logan is moving in the same direction and it is in the positive direction. The required is the net force. And then the equation, the one that we have mentioned based from the impulse momentum theorem, since meron tayong mass, meron tayong initial velocity at final velocity, tapos meron tayong time. Ito yung best na equation na gagamitin natin. Okay? Next. For solution, we just substitute and the result would be negative 3,515 newtons. Bakit negative? Okay, kasi it is, sorry. What happened? Because it is acting in the opposite direction as the body of Logan. Stopping force. Stopping force is a force that is negative. No? Kapag pinabagal ka ng isang force, ibig sabihin nun, opposite yung direction niya doon sa magiging direction mo. Next. NASA's Langley Research Center has been experimenting with the use of airbags to soften the landings of crew exploration vehicles or CEV on land. What stopping time will be required in order to safely stop a 7,250 kilogram CEV moving at 7.65 meter per second with an average force of 426,000 newtons. Ayan, no? So, kung mapapansin nyo, tatlo lang yung given natin. Pero, pag sinulat na natin siya, naging apat siya. Bakit? Because, meron tayo ditong tinatawag again na invisible given, which is told to us or inferred to us by the word safely stop, stopping time. Okay, so we can assume na titigil yung object, no? So, ang mass niya is 7,250. The initial velocity is 7.65. And then, since mag stop nga siya, the velocity is 0. Now, bakit ni-negative ko tong net force? Okay? Kasi, again, this is going to be a stopping force. A force that will try to stop our object. And it should be in the opposite direction as the movement of our object. Kasi kung gusto mong patigilin ng object, ba't ka naman mag-a-apply ng force sa kanya na same ng direction na pupuntahan niya? Hindi mo siya mapapatigil doon. Dapat opposite. All stopping force are in the opposite direction as the object that they are trying to stop. Okay? So, paano mo mapapatigil ang korupsyon kung nakikis-ayon ka sa direksyon ng korupsyon, di ba? Dapat you go against the flow of corruption para mapatigil mo siya, di ba? Okay. So, the same goes with force. For you to be able to stop something, the force must be in the opposite direction and the negative sign is the one that denotes that it is in the opposite direction. The required is the time of impact or stopping time. And then from our equation again, may given tayong mass, may given na initial and final velocity, at may given na net force. Kaya ito yung equation na gagamitin natin for this. Again, galing yan sa impulse momentum theorem. For the solution, we just have to substitute and we would get the answer time or stopping time would be 0.13 seconds, which means that for you to be able to stop a 7,250 kilogram crew exploration vehicle moving at 7.65 meter per second using a force of 426,000 newtons, it will take 0.13 seconds. So, di ba ang bilis lang? Kasi ang laki ng force na ginamit, no? Okay, so here's a little activity that we could analyze. We have the following characteristics and we have this case 1, case A, and case B. For the first characteristic, you just have to identify which case best suits the characteristic. Number 1, greatest velocity change. Which one? The answer is letter B. Ito. Kasi remember, ayan, may VI tsaka VF tayo. Sa case A, solve natin, no? Case A is ito magiging computation natin ng delta V equals ito going to the east siya, so 10 tapos minus ito going to the west -5. So i-consider pa rin natin yung directions kahit change siya kasi velocity to. Lagyan natin ng dito. So that's going to be 15. Okay? Tapos try natin yung sa case B. Delta V is equal to 30 minus -28. And our answer here would be 58. Okay? Kaya letter B yung greatest velocity change. Kasi ito naman yung may greatest acceleration. Siyempre, we know that acceleration is change in velocity. So kung sino yung may greatest change in velocity, siya rin yung may greatest change in acceleration. Okay? Next. Siyempre, alam naman natin that from our equation, delta P is equal to M times delta V. Ayan. Mas mataas magiging change in momentum pag mas mataas ang change in velocity. So, ang sagot din natin dito ay letter B. And then lastly, the one with greatest impact would also be letter B. Bakit? Kasi remember, impulse is dependent upon net force and time. And net force is dependent upon mass and acceleration. So kung sino yung may mas malaking acceleration, siya yung may mas malaking net force, therefore siya din yung may mas malaking impulse. Okay, thank you for listening to the part 2 of momentum impulse relationship. Up next, we're going to discuss collision and the different types of collision. And this lesson is also divided into part 1 and part 2 kasi masyadong mahaba kapag isang part lang siya. Yan lang. Bye!